Okay, now what is this acceleration due to gravity? Now this acceleration due to gravity is actually they we experience it when we are having free fall. Now what is a free fall, right? Free fall. Free fall, that means you can either move up or you move down, right? And you allow the object to move up and down inside the gravitational field. Inside the gravitational field, and there is no other obstruction. Purely the motion is purely under the control of gravity. That's all. It is purely controlled by the gravity. We assume that there is no wind resistance, there is no air resistance. You see, sometimes when the wind is blowing, it will affect the motion of the object. Or sometimes because we are moving around in the atmosphere, there is also this air resistance that will affect the motion of the object. Now, for these two cases, whether it's due to the wind or due to air resistance, we assume it is negligible, right? So if it is negligible, then the motion is under free fall, purely subjected to gravitational attraction. That's all. No other forces involved. Uh, the ideal one should be inside a vacuum. Actually, in US, there's one abandoned nuclear reactor, very very big nuclear reactor, abandoned one, surrounded by concrete, and they have converted this abandoned nuclear reactor into a vacuum. So inside they can actually suck out the air. They have a something like a vault. The door of the chamber is like a vault. Then they can seal it up and suck out the air from the chamber, which is the abandoned nuclear reactor. So inside vacuum. So they perform the experiment inside there. They use a feather and they use a ball, and they drop it together. They see that the feather and the ball, it reaches the bottom of the nuclear reactor, which is now converted into a vacuum, and they reach the floor together. So it shows that under free fall, the gravitational attraction is always the same, right? Whether it's for big object, heavy object, and so on. If it is free fall, they will fall at the same rate. The acceleration due to gravity is the same. Okay, right. So I look at the first one. Okay, a freely falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. Now, regardless of its initial motion means you either throw the object. When you throw the object, the initial motion is actually, it is moving already. It is moving. Or you can actually hold the object with your hand and you just release it. So that means in this case, the initial velocity is zero. Or you throw the object. When you throw the object, the initial velocity is not zero. The initial velocity is not zero. So whether the initial velocity is zero or not zero, they say it doesn't matter. As long as the object is subjected to gravitation alone, then it is free fall. Without air resistance, without wind resistance, under influence of gravity alone, that is called free fall, right? So this is the first thing that they say about a free fall. Okay, then we look at the second one. Objects thrown upward or downward and those released from rest are all considered free falling. This is actually talking about the earlier part here. regardless of its initial motion, right? So whether you throw it or whether it is released from rest, it is still a free fall. Any question about free fall so far? Free fall is just about purely gravitational pull, acceleration due to gravity only. You are under the influence of gravitational force, that's all. No other forces involved. Any question regarding this free fall? No.
No.
Yes.
No.
No. Okay, next. Next. The magnitude of all the free fall acceleration is denoted by the symbol g. This is a standard notation, g. G represents the acceleration due to gravity. Okay, any textbook when in physics when they use the symbol g, it means the gravitational acceleration due to gravity. G is actually an acceleration. G is actually the acceleration. It's acceleration due to
So
gravity.
can you repeat? Can you can you repeat the part again? I think you lagged out, so I didn't hear any word you said.
Okay, one more time. So when an object is experiencing free fall.
Oh, so I think wait, I think it's my internet. Let me change the Wi-Fi for I might disconnect for a bit. I think it's my internet. Give me a sec.
Okay or not?
Hello, can you hear me? Oh, okay, I'm back.
Okay. I can speak louder now. I can speak louder
Okay.
now. Okay, right. Uh, yes. When the object is experiencing free fall, the acceleration during the free fall is represented by the symbol g. So g is actually acceleration. What type of acceleration? Acceleration due to gravity. The value of g decreases with increasing altitude and varies slightly with latitude as well. Okay, now here it means that if the object is around the surface of the earth, I mean not very far lah, I mean about within 10, 20 meters or from the surface of the earth, the acceleration due to gravity is always the same. The value will not change. But if you go higher and higher into the atmosphere, higher up, then the value of g may change. The value of g may change. And how does it change? They will become smaller and smaller. As you leave the surface of the earth, you move further and further away from the earth, the acceleration due to gravity will become smaller and smaller. Okay, so there is one factor that will affect the acceleration due to gravity. So the second factor that affect the acceleration due to gravity is the latitude. Now, as you know, latitude is the position on the surface of the earth. Okay, at the equator, you know equator, isn't it? At the equator and at the north pole, the acceleration due to gravity may change slightly. Okay, on the surface of the earth, it depends on the latitude. Latitude at the equator, the latitude is 0 degrees. Now, north pole or south pole, the latitude is 90 degrees. So at different position on the surface of the earth, the acceleration due to gravity may also change slightly, right? Okay, so these are the two factors that will affect the g. But normally, for our calculations, because we are within the same area, the same vicinity, and it is not very far from the surface of the earth, we assume that the value of g is always the same. And this value, they say, you can assume it to be 9.8 meter per second square. So this is how the gravity will affect our motion, 9.8 meter per second square. So sometimes for approximate use, they use it as 10 meter per second square. But this one, unless they tell you use 10, you don't use 10 because it's a very rough figure. The more accurate acceleration due to gravity will be 9.8 meter per second square. Okay, so this is the value of g. Next part. If we neglect air resistance and assume the free fall acceleration doesn't vary with altitude over short vertical distance, then the motion of a free falling object is the same as motion in one dimension under constant acceleration. Okay, right. Now, what is the meaning of motion in one dimension? Motion in one dimension means moving along a straight line. Whether the straight line is horizontal, you just move, go and come back, or the straight line can be you just go up and you come down. You are not moving at an angle, right? So it's something like you move like that, then you turn around, or maybe, how to say, once you move like that, then you turn a bit. That means we have two dimensions. We have the x and y. So this x and y will be two dimension. But for this case, we are only studying one dimension. They just move along a straight line. They don't turn like how to say, they don't turn to the left, or they don't turn to the right. So that will be one dimension. Okay, right. Where is it? Here, under constant acceleration. So, but this is not the case when you go to the next chapter. The next chapter is two dimension, right? The the movement will be, you can turn around, right, at different angles. So only in this chapter we are studying one dimension. And for this free fall or acceleration due to gravity, we are going to adopt a certain convention. Convention means we fix it that way, mutually agree that we are going to use this standard. It is the meaning of convention. I don't know. You understand what is the meaning of convention or not? Convention means we all mutually agree on all the rules. The rules. Okay. What are the rules that we agree on? Okay. So the convention that we agree is define up as positive direction. Earlier on, the convention that we adopt is going towards the right is positive, going towards the left is negative. But now, since it is moving up and down, we are going to adopt another convention. So the other convention is going up is positive, going down is negative. And the symbol for position, because it's going up and down, we call it y. We don't call it x lah. We call it y. So y, the position variable. Okay. Now, in that case, the acceleration due to gravity, the A is actually negative g or negative 9.8 meter per second. Now, since we are moving up and going up is a positive direction, the acceleration due to gravity is actually pulling the object down. It is pulling the object down, that means the acceleration is in the opposite direction. That is the reason why there is a negative sign in front of the acceleration there. This is a matter of convention. Why we call it convention, mutually agreed condition? Because you may say, I don't like this. I want to say go down is positive, go up is negative. Is it possible? Of course, yes, right? If all of us agree to this convention, then you can say going down is positive, going up is negative, right? No? So it's a matter of mutual agreement. It is not a scientific fact. It is not a scientific fact. It's a matter of convention. We agree to this system, right? So that is the meaning of convention. So we agree that going up is positive, right? Maybe you go to another planet or another system. You say we want to go down as positive, go up as negative. Actually you can do it, right? Now for the convenience of for the convenience of all of us studying this topic, so all of us agree that going up is positive, going down is negative. So let's say you are standing on top of a building. You are standing on top of a building. This thing is actually a building, or it can be a cliff. You are standing here. So your position here, this level here is 0. This position is 0. So we call it y equals to 0. Earlier on, we used the symbol x. Now we use the symbol y because it's up and down. So here the position is y equals to 0. So as you move up, the position here may be y equals to a positive number. So it can be positive 1, positive 2, positive 3, positive 4, y equals to positive 5, and until here, maybe y equals to positive 10. So above this horizontal level that we fixed, all of it, the y is positive. So we say going up is positive. So let's say your velocity, you throw a ball upwards. So all this velocity that is going up is positive velocity. All the velocity that is going up is positive velocity. All right. But because the gravitation is pulling it down, so the g is negative 9.8. Okay. So in this quadrant, okay, in this area here, the position is positive, velocity is positive, only the acceleration due to gravity is negative. So this is the convention that we are going to use. But when you throw or you project an object upwards, it will reach the maximum height. Then it will fall back vertically downward. Actually, it is not like this, you won't move out a certain distance and come down. It won't like that. It is not like that. It's actually going up vertically and coming down vertically along the same line. It is not this turn here. There's no turning here. This turning is actually we draw it to separate the two lines so that you can see one is going up, one is coming down. Actually, this line here actually is overlapping with this line. This line is actually overlapping with this line. How to make it possible? Maybe you put your hand outside here. Oh, because this is the building or the cliff. So you put your hand outside there, you throw something up, then it will come down along the same line. Okay or not? Actually, they are the same line, but I draw them as two different lines for for the sake of looking at it clearer, right? Actually, they are moving along the same line. Okay, now when it reaches the maximum height, it will stop instantaneously, then drop down again. On the downward journey, because the velocity is moving down, so the velocity here is negative. How about the acceleration? The acceleration is also negative because acceleration is pointing downwards, is pulling the object downwards. So at this position, when it's moving down, both the velocity and the acceleration is negative. Now, how about the position? The position here is positive because it's above this line here. It's above this level. So the position here is positive. So when it passes this position, the zero level, and further below, then all the three of them, velocity is negative at this position, velocity is negative, acceleration is negative, the position is also negative. The position is also negative. So let's say we have three part. Okay, the first part of the journey is going up. When you're going up, displacement positive, velocity positive, only the acceleration due to gravity is negative. On the downward journey, okay, on the downward journey for this part, displacement is positive, velocity is negative, acceleration due to gravity is negative. Okay, so this is for the downward journey. But after the horizontal line, after the horizontal level here, this part, the displacement will be negative, velocity is negative, acceleration due to gravity is negative. So altogether, we have three possible scenario, scenario. One is going up, the other two is for coming down. Any question with the convention that we are going to adopt?
No, no.
No, all right. So you know going up, two things positive, right? Position and velocity positive. Coming down, velocity is negative, position can be positive or negative. But throughout the journey, the acceleration due to gravity is always negative, whether you are at the top or at the bottom, whether you are going up or coming down, acceleration due to gravity is fixed. It is always negative 9.8. Okay, so this is the convention that we are going to adopt. You read this question.